start. Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So students, in yesterday's class, we have started the chapter ray optics, that is the branch of optics. Now, definition of light, some revisional concepts are there. Definition of light, light is what is a form of energy where it produces sensation of vision to our eyes and make the object visible. So student, I want to know in the spectrum of light radiations, how many type of waves are there? Tell me please. How many type of waves are there in a radiation of light? Yes, exactly, students. As sun is the source of energy that gives us the light radiations. Okay, and in the form of light radiations, there are three types of waves. First is the very less frequency wave is called infrared waves. Okay, then second is visible, and then UV rays, UV waves actually. Okay, and all the waves are coming in the form of rays also because the direction of waves is called a ray. Okay, so when there is propagation of wave itself, it is propagation of rays also. Okay, because the direction of a wave is called a ray. So this is a ray, and these are wave fronts called, these collections are called wave. So student, in out of three type of signals, only visible signal having a capability to produce the sensation of vision. Yes. So light is a form of energy which produces sensation of vision. So we are talking about only visible ray here. Okay. Visible ray. In this optics, we have to talk only about the spectrum of visible wave or visible ray to our eyes and make the object visible. So the branch of physics which deals with the study of nature of light. Now, what to study? Studying the nature of light, its properties, its effect and propagation is known as optics. Optics is of two forms. One is called ray optics and ray optics or geometrical optics, and then second, wave optics or physical optics. Now tell me, what is ray optics and what is wave optics? What is the difference between ray optics and wave optics? Student, please tell me. Do you feel any difference between ray optics and wave optics? Hmm. Listen carefully, students. See here, in the branch of optics, in branch of physics, which we deals with the study of nature of light, its properties, effects, and propagation of optics. The propagation is known as optics. So focus the word propagation. When you study only about the propagation of light, means direction of propagation. Yes. Okay, in which direction light is propagating, and you study the type of propagation, then this optics, this part of optics came under the category of ray optics or geometrical optics. Clear or not clear? Yes. So the branch of optics that deals only with the propagation of light. Okay, and propagation of light takes place in the terms of rays which are valid if size. Okay, in the terms of rays, this optics is called geometrical optics. One more thing, ray optics or geometrical optics persist when the size of optical is large in comparison with the wavelength of light. Yesterday we have read that. Clear? Yes. To visualize the ray optics, the size of the obstacle should be greater than the size of the light, or you can say wavelength of the light. Clear? Second, now what is wave optics? Wave optics is related with the properties and nature of the light. Yes, nature of the light, properties of the light, various effect, okay, of the light. So this is called wave optics because light is essentially a wave. Light is a wave, okay? And direction of wave is a ray. What is a ray? Ray is only direction of wave. Direction of wave is called a ray. Clear or not? So when you study about the wave, that comes under the criteria of wave optics. The branch of physics deals with the wave phenomenon like interference, diffraction, and polarization. These all are the wave phenomenon of light, okay, called wave optics. Now, tell me the characteristics of light. What do you know about the light? What are the characteristics of light? Yes, tell me, please. Yes, exactly. The light speed of light in vacuum equals to c 10 to the power 8 meter per second. But tell me what happened when light came from one medium to another medium? Does it speed changes or not? Yes, exactly. In one medium to medium, the light speed of light vary. The nature of light is transverse or longitude. Light waves are transverse or magnitude? Longitude. Exactly. Light waves are electromagnetic waves in nature. Okay, and they are transverse in nature. Speed of light, we have talked already about this. The speed and wavelength of light change when travels from one medium to another medium, but its frequency remains unchanged. Very important. Make the formula, write the formula C equals to nu lambda. Okay. Now, there is a relation between speed of light and wavelength. Okay, exactly. Actually, C for vacuum. This formula is applied for vacuum. Okay, vacuum. And for medium, the formula is V equals to N lambda. V equals to nu lambda. Right? M equals to mu lambda or V equals to l- nu lambda. So lambda upon time period. Why? Because nu equals to 1 upon time period. Write it. Okay. Yes. So frequency of a light wave always remains constant. Remember this, frequency always remains constant. This means V and lambda are variable. If lambda increases, then velocity also increases. Clear? On increasing lambda, velocity of the light also increases. So V proportional to lambda. So the speed and wavelength of the light can be changed when a light traveling from one medium to another medium, and frequency always remains unchanged. Okay. So frequency is like a Aadhaar card of the light signal. Okay. If a light can go anywhere, its frequency remains unchanged. Done. So this is about frequency, and one more important formula. V is equals to lambda by T, and 1 upon T becomes nu. So V equals to nu lambda. Sometimes it is also called V equals to F lambda. F is fault frequency. Clear? Nu lambda, not mu. It is nu. Nu nu. Okay. Nu, new lambda. Nu is means frequency. Yes. How did F come? Actually, in the place of nu, you can use F. Nu is equals to F. Okay, so it is also called F for frequency. So V equals to F lambda. Okay. For any medium, V is equals to F lambda. So if lambda increases, velocity is also increases. Clear? So the wavelength of the red color is greater than wavelength of the violet color. Clear? That's why speed of the red color is greater than speed of the violet color. Clear? Because speed is directly proportional to lambda. So lambda red is higher than lambda violet. So the speed of violet red color is higher than the speed of violet color ray. Clear? Now tell me types of object. There are two types of object. One is luminous and another is non-luminous. Luminous, they having the object having their own light, okay, are called luminous, like sun and other stars and oil lamp are called luminous. Non-luminous, the object which do not emit its light but become visible due to the reflection. Important, like all the things you see in your table, like mouse, like your pen, like your copy, the things are visible to you because of reflection. Clear or not clear? Yes, because like a mouse is there. Okay, so you can see your mouse. Why? Because your tube light or your ceiling bulb reflected the light getting reflected here and come back to your eyes. Then you can see this mouse. Okay. So this is luminous and this part is non-luminous. Got it? So this is non-luminous object. So the object which do not emit own light become visible only due to the reflection of light falling on them is called non-luminous object like moon, table, chair, etc. Yesterday you ask what is beam? Bundle of adjacent light rays. So many light rays are there. Then this is called beam. Okay, collection of so many light is called beam. So beam may be any type. Parallel beam may be there. Divergent beam may be there, and convergent beam may be there. Okay. So divergent beam, convergent beam, and parallel beam. Clear, beta? Now, type of images. There are two type of images are there. One is called real image, and second is called virtual image. What do you mean by real image? Tell me, students. What is real image? Mm. Yeah, it is form on the screen. This is one aspect of the real image. That real image can be obtained on the screen. Now, few more lines. Actually, real image means there is the real meeting of the light rays. Clear? And virtual image meeting means that there is the virtual image, a virtual meeting of the light rays, or you can say they are appeared to meet, not actually meet, they are appeared to meet only. Okay. So the image obtained by real meeting of light rays is called a real image. It is always inverted. Remember, when there is a real image, it is always inverted. Okay. Yes. And virtual image, the image obtained when light rays are not really emitting but appears to meet only is called a virtual image. They just appear to meet. Clear? Now, reflection of light, we have seen yesterday, angle of incidence equals to angle of reflection. And the laws of reflection, angle of incidence equal to angle of reflection, and the incident ray normal to the mirror at the point of incidence, refracted ray all lying on the same plane. Clear? We have discussed the type of mirror. What is a mirror? Mirror is a smooth, highly polished reflecting surface is called a mirror. Type of mirror, there is a plane mirror. First type of mirror is a plane mirror. Plane mirror is a highly polished plane surface is called plane mirror. But plane mirror, uh, only few lines are related to plane mirror that in our syllabus. Different properties of image formed by a plane mirror are given below. First, right, in a plane mirror, size of image equals to size of object. Clear, beta? Size of image equal to size of object. Now, one more term related to the mirror, that is called magnification of the mirror. So, magnification of the mirror produces by height of the image divided by height of the object. Clear, beta? Height of the image divided by height of the object. Now, for plane mirror, if height if height of the object is x, image is also x. So the plane mirror, the magnification equals to 1. That is called unity. Clear? So m equals to 1. For a plane mirror, m equals to 1. One more thing, distance of image from the mirror, that is equal to distance of object from the mirror. Like this is a plane mirror and a man stands here at a distance of 5 meters from the mirror. His image will be formed, virtual image will be formed 5 meters behind the mirror. Clear ki not? Yes. So this is the concept, distance of image from the mirror is equal to distance of the object from the mirror. Got it? The plane mirror may form virtual as well as real image. Yes. Many of the people knows that plane mirror is only form virtual image, but no, plane mirror can also form a real image. Okay, so right, a plane mirror can form virtual as well as real image. Plane mirror will form plane mirror will form virtual image when your object is real. When your object is real, then the plane mirror will form real image. Clear? Yes. So when your object is real, your plane mirror will form virtual image. Check here. Object is real and your image is virtual. Clear? But when your object is extended object, or you can say virtual object, when your object is virtual, then plane mirror will form here. Real. Here it is virtual image and here it is real image. Wait. Extended object and image. Yes, a plane mirror may form a virtual as well as real image, but in this example, both we having the virtual image. Yes, the here it is also virtual because object is real here. Okay, for real object you will have a virtual image. Clear? Yes. For virtual object you have a real image. Yes, this is the formation of image. Virtual object. For virtual object, your object is virtual and your image is real. Clear? Okay, done. Yes, spherical mirror. All the things are not in our syllabus. Next, spherical mirror. We have read that a spherical mirror is a part of hollow sphere whose one side is reflecting, other side is opaque. Mirror are two type, concave mirror and convex mirror. Concave mirror whose reflecting surface is towards the center is called concave mirror. Okay, and whose reflecting surface is away from the center of a sphere of which mirror is a part is called convex mirror. Now the definition. Pole. The middle point or center of the spherical mirror is called vertex or pole in the mirror. It is represented by P. Center of curvature is the center of the spherical mirror. Okay, center of curvature of a spherical mirror is the center of the sphere of which the mirror is a part. It is represented by C. Got it? Radius of curvature is the distance from the pole to the center of curvature. It is represented by R. Principal axis is the imaginary line that joining pole to the center of curvature. Linear aperture is the effective diameter M1, M2, M1, M2 of the mirror. Clear? This is called linear aperture. Angular aperture is the angle made by the aperture par at the center. The angle M1C M2 subtended at C by the diameter of the spherical mirror is called angular aperture. Now definition of principal focus. Yes, this is important. Now tell me the definition of principal focus. What we have read yesterday. Okay, define principal focus, beta. Principal focus, sorry. What is principal focus? Student, what is principal focus? Principal focus is a point on the principal axis of the mirror at which the light rays coming parallel to the principal actually meet after reflection. This thing is very important. This line is meet after reflection. The rays coming parallel to the principal axis after the reflection meeting at a point on the principal axis. This point is called principal focus. Clear? For the concave mirror, the rays actually meet at that point. And for the convex mirror, they are appear to meet. They are appear to meet. Okay. Okay. Must make the diagram if principal focus is asked. For concave mirror or converging mirror, principal focus is towards the center of curvature. And for, sorry, it is in both the cases, it is towards the center of curvature. Okay. But in the case of concave mirror, it is front of the mirror. And in case of convex mirror, it is behind the mirror. Understood? This reason, this polished part is called behind. So here the focus is behind and focus is virtual and behind the mirror. And here the focus will be real and front of the mirror. Yes. So now you can see the light rays are get converged here. So the concave mirror is called converging mirror. And here the light rays are diverged. They are appear to come from the focus. So this type of mirror is called diverging mirror. Got it? This mirror is called diverging mirror. Focal length, the distance from the pole to the focus point is called focal length. And we already have this sign convention. Now, next, first derivation, relation between focal length and radius of curvature. So, what is the relation between focal length and radius of curvature? It was F equals to R by 2. Clear or not? But student, today we have to derive this one. Let us derive this. How to derive F equals to R by 2? Consider a concave mirror of a small aperture. We have a mirror with very small aperture. Okay. Very small aperture with pole P. At pole P, yes, this is the pole center part of the mirror at pole P. Principal focus as F. Yes, F is the focus, means when a light coming parallel to the principal axis, when a light coming parallel to the principal axis after the reflection, it will passing through a fixed point that is called focus. Got it? And center of curvature is C. C is the center of curvature. Clear? Then by definition, P and C, P to C equals to R and P to F is equals to small f. Clear, student? Now check here. This is angle of incidence and this should be angle of reflection. Agree? This is I, above one is I and the below one angle is R. Got it? Yes. Angle of incidence, angle of reflection. Consider a concave mirror of a small aperture with pole P with principal focus F and center of curvature C. Then by definition, PC equals to R and PF equals to small f. So by the figure, check these angle ABC equal to I and angle CBF equals to R. Clear or not clear? Now tell me if this angle is I, this is also becomes I. Yes or no? By alternate interior angle, this angle I, so this also becomes I. Got it? You. So I equals to R. And in next, I equals to R. As I equals to R, so this angle becomes equal to this angle. Now check the figure. Here it is like this. Here it is I and here it is R. And both the angles are equal. Clear or not? So by the theorem in mathematics, if opposite angles are equal, then their corresponding sides, opposite sides are also equal. So this one side CF will equal to the opposite side BF, right? The side CF will be equal to the side BF. Got it? Yes. So angle ABC equal to angle CBF, I equals to R, and angle BCF equal to angles FBC. So triangle is become isosceles. How? This side and this side become equal. So the triangle become isosceles. And so CF equal to BF. CF equal to BF or FB. Clear? Hmm. Now, if the since the curve aperture of the mirror is very small, so this point B is very approximated, nearly approximated to point P. Clear? As the aperture of the mirror is very small. In optics, we have to take the aperture of mirror is very small. So B to B point is very close to P. Clear? B point is very close to P. Clear? This means F to B can be considered as F to P. Yes or no? FB can be considered as FP. Got it? So BF is equals to BF FB is equals to PF. The distance from B to F will exactly equal to distance from P to F. Clear? Now we have PC equals to CF plus PF, right? We have PC equals to, I'm writing here, PC equals to CF plus PF. Check here by using blue pen. PC equals to CF plus PF, CF plus PF. Okay, beta. PC is equals to CF plus PF. Now CF is equals to BF. Yes or no? In the place of CF, I can write here BF because CF become equals to BF. Yes or no? So PC equals to BF plus PF, right? As I said, BF equals to PF. So you can write PC is equals to, in the place of BS, again it is PF and again it is PF. So PC becomes 2PF. Agree? What is P to C? P to C is equals to R. And twice of what is PF? P to F is equals to F. Here it comes derivation. PF equals to, sorry, R equals to 2F. So F equals to R by 2. Can you write like this? So this is the complete derivation for first derivation of the mirror, F equals to R by 2. Any problem? Okay, done. Next is image formation for concave mirror. All the cases are related to class 10th. So students, I think all you know well aware about these cases, but let us discuss between C and F. So we have a concave mirror. So first take a concave mirror of appropriate aperture and make a principal axis here. Now, if this is your focus point, this is your center of curvature. Now take a object B, A. A is the pointed one. Now, a first ray, not line, first ray that is getting parallel to the principal axis after the reflection passing through the point of focus. Clear or not? Yes, this one. Now, second ray, you can pass through focus. Second ray that is passing through focus after the reflection will getting parallel to the principal axis. Yes or no? Yes. So after the reflection, it getting parallel to the principal axis. And here it is the image point. So you can make a image point is here. So check. Here the image is real image. You have a real image. Okay. Real image is always inverted. It is larger than object. Clear? It is larger than object. Your object is smaller and the image is larger. That is called magnified. Magnified larger image. Clear or not? Yes. So check here. When the object is between C and F, your image is formed beyond C. Yes. Check here. Your image is formed beyond C. C is this point, and your image is formed here. This point is B dash, and this is A dash. Okay. So your image is formed beyond C. It is enlarged. It is real and inverted. Clear? Yes. Next, at focus. So simple. When your object is at focus, then what will happen? A diagram will form like this. This is your mirror. Now, this is your focus point. Now your object is on the focus. Then what will happen? The ray is coming parallel to passing through the focus. Clear? And second, that is inclined on at angle I. It will having same angle and passing parallel. So there is no scope of meeting of these line as they are getting parallel to each other. Okay. So they're getting parallel. So where the image will form, I will say at infinite. The image will form at infinity. Clear? Yes. So at infinity, image will form infinity. If it is formed at infinity, definitely it may be very enlarged, real and inverted. Clear? Next case, this is the case of shaving mirror when the object is between pole and focus. Very important one case. When object is between pole and focus. Check. This is our mirror. This is our principal axis. This point is pole and this point is focus. Clear? Now your object is lying somewhere here. So first ray that is getting parallel to the principal axis after the reflection, it is passing through the point of focus. Clear or not clear? Now some point C is also there. Now when a ray and that is, yes, you can take another ray that is passing from the pole through the pole, it will form the same angle and will have like this. Okay. Now see there is a constant difference is increasing. Here the difference distance between the two rays are increasing continuously. So they are not supposed to be parallel. They will intersect at some point. Now, if they intersect at some point, you will have a virtual image because in the real time, the images, these rays cannot meet. Yes or no? If you extend up to infinity, they will not meet. So they can meet at some point on the behind of the mirror. And here you will have a virtual image. So if this point is A, so the pointed one is called A dash and this is B dash. Clear? So the image is here virtual and erected and size is bigger than your object, magnified image. Clear? So between object is P and F, your image is formed behind the mirror. Yes, this reason is called behind the mirror. Okay, this reason is behind the mirror. Your image will be enlarged and virtual and erect. Clear? Image will be virtual and erect. Got it? Remember, when the image will be virtual, magnification will be positive because the image is virtual and virtual image is always erected. Okay. And for the real image, as the image will be inverted, so for the real image, magnification will be negative. Yes. Negative magnification means your all image is inverted, and positive magnification means your image is uh, erect. Yes. M is positive means image is erect. That is a straight image. Okay. Erect. Clear, students? Now, next case is image formation in convex mirror in different position of the object. So for the convex mirror only, there are two valid cases are there. First, this is a convex mirror. So first case, when your object is at infinity, so from infinity the rays are parallel. Okay. In a parallel, if a parallel rays are coming on the convex mirror, they getting diverged like this. Okay, in this situation, they are appear to be come from the focus. So if you're talking about their image, so their image will be virtual and formed at the point of focus. Clear or not? So, hmm, yes, here at infinity, your position of the object at infinity, position of the image is at the focus and behind the mirror. Got it? Yes, your position of the image will be at the focus, and this reason is called behind the mirror. Behind the mirror. Clear? Size of the object, size of the image, it is highly diminished point size and virtual and erect. Clear? Yes. Next case, when your object is between infinity and the pole of the mirror, means other than infinite, you can place your object at any of the places on the principal axis other than infinity, because at infinity lines are getting parallel to the principal axis, but other than infinity you have placed your mirror like this here. Okay, you can place you placed your object here, AB. Now what happened, first ray that is coming parallel to the principal axis, after the reflection it will be diverged and appear to be come from a point focus, because virtual focus will act. Clear or not? Yes, parallel rays diverged, okay, and it is appear to become from a fixed point, that is called focus. Second ray, another ray, you see, if a second ray is here, that ray is focusing towards center of curvature, then what will happen? Yes, this ray, the second ray is focusing towards the focus. Check, the focus of the ray is towards focus. So it will retraces its same path. Yes or no? The ray is coming towards the center of curvature will retrace its same path, its own path. Clear? Clear? So the ray will, by retracing its same path, get diverged outside. Now, if you extended both the rays, you will have the image virtual image of this object. So if the upper one pointed one equals to B, here you will have a B dash and here A dash. Clear or not? Yeah, so this is your image. Okay, so between infinity and the pole of the mirror, you can place object anywhere. Now your object, sorry, your image will be formed at P and F behind the mirror. Check. Here your image is formed between pole and focus. Got it? Images between pole and focus. Image is between pole and focus. Clear? Images between pole and focus. And next, the size of the image. Tell me the size of image. Does it is greater than the object or lesser than the object? It is lesser than object. This is called diminished. Clear? Yes, it is diminished. Clear? The size of the image is diminished and the type of image is virtual and erect. Clear, beta? Now, so this is completed all the cases. Now next, mirror formula. So what is mirror formula? Yes, numerical. For numerical it is very important. 1 upon f equals to 1 by v plus 1 by u, or 1 upon u plus 1 upon v. More better if you learn it with the 1 upon v plus 1 upon u. Okay, because in length formula there you have to insert only a minus sign, but not here. Okay, so this is mirror formula. Now we have to derive this mirror formula. Okay, mirror formula, simple relation between distance u of the object distance from the pole is called u from the mirror. Okay, the distance v of the image from the mirror and the focal length of the f is of the mirror. This relation is called mirror formula. So 1 upon f equal to 1 upon u plus 1 upon v. This is called mirror formula, valid for both concave and convex mirror. Clear? Now derivation for this mirror formula. Yes, how to derive? First, make a clear ray diagram. Students, you have to make a clear ray diagram to derive this one. Okay. Yes, check. First, you have to take an object. Now, the ray coming parallel to the principal axis after the reflection passing through the focus. So, like this. Okay, so this one become u. The distance of the object become u. Clear? Now, another ray, you can take only one ray. Okay, this one, the second ray only. Okay, it is getting parallel after the reflection. It getting parallel like this. So two rays are there. First, this one, the parallelly that is getting coming parallel to the principal axis after the reflection passing through the focus. Now, this is your image called A dash B dash. Okay, A dash B dash. This will be your image. Got it? Yes. So check what you have. You have the distance of object from the pole of the object AB is called U. This is the focus point and the distance from the focus point is considered as a small f. This is image distance is called a small v. Okay. Consider this point as E. This pole is called P. Okay. Now, starting the geometry, first you have to take from a pair of similar triangles. Now you have two triangles. Check the triangles. First triangle is ABC, the bigger one triangle ABC and B dash A dash C. Clear? Both B dash A dash C. Both the triangles are similar. Why? Because two angles are equal. This angle is equals to 90. This is also equals to 90. And these two angles are vertically opposite angle. So these two triangles are similar. And in the case of similar triangle, we can write perpendicular upon perpendicular equal to base upon base. Right or wrong? So perpendicular, what is perpendicular here in this triangle AB? So AB, here it is perpendicular A dash B dash. So perpendicular upon perpendicular means AB upon A dash B dash equal to base upon base. Here base equal to BC and here base equal to B dash C. Clear? So by the similarity, yes, in using singular triangle concept, the sides are proportional. So perpendicular upon perpendicular equal to base upon base. Got it? So we have completed this one for the first type of triangle. First two triangles completed similarity. Okay. Now to another triangles. A dash B dash F. Yes, A dash B dash F. Check this one triangle. Where is A dash B dash F? By using this one color, pink color. Yes, check. This is A dash B dash F. Okay, A dash B dash F. A dash B dash F is similar with E P dash F. Yes, the upper one. Clear or not? F. E P dash F. Yes. For P dash, you have to draw a projection over this. So take a point P dash that is very close to P. Okay. So this point is P dash. Clear? So P point is very approachable to P dash. So there is no difference at all because for a small aperture, P is very closer to P dash. Clear, beta? So E dash, P dash F. Clear? So both the triangles are similar. Why? This is 90 degrees, so this is also 90. And if this is some angle theta, this will also theta. Clear or not? Now apply the similarity. So similarity will be here. First, P dash E perpendicular P dash E upon this one perpendicular AB dash AB dash equals to base P dash F P dash F upon B dash F. Right? Got it? So in the triangle P dash E upon A dash B dash equals to P dash F upon B dash F. Yes. Okay. Now, in the place of P dash E, you can write AB because P dash E equals to AB as it is parallel. Check here, yes or no? In the place of P dash E, here it is P dash, here it is E. P dash E is parallel to AB, yes or no? Both the length are equal, my dear. This is AB and this is P dash E. So both are equal. Clear? So in the place of P dash E, you can put what? AB, right? So you can replace P dash E with AB. So this derivation becomes what? P dash E replaces with AB. So it will become in the place of P dash E, put AB upon A dash B dash equals to P dash F upon B dash F. This is equation number 2. Clear or not? First it was from the first two triangles and then after replacement, this one. Clear? Now, you check in the equation number 1 and 2, the left part are equal. The left part is here. What is left part? AB upon A dash B dash. Okay. And here it is also left part AB upon A dash B dash. So if left part are equal, then right parts are also considered as equal. Okay. So right part, make the comparison of right part CB upon CB dash equals to P dash F upon B dash F. Got it? Yes. Now, what is CB? Check CB. 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 Can you write CB as PC minus, sorry, CB. CB is this one. Can you write CB as PB minus PC? CB equal to PB minus PC. Yes or no? Yes. So CB can be written as PB minus PC. Yes. CB equals to PB minus PC. Can you write CB dash as PC minus PB dash? Check CB dash. CB dash may be written as PC dash minus PB dash. Okay. So you can write it PC minus PB dash. Click OK. Now P dash F. I said that P point is very close to P dash. So in the place of P dash, you can take P also. So P dash F become PF. Okay. Now B dash F. Where it is B dash F? This is B dash F. So B dash F. B dash F may be written as PB dash minus PF. This is equals to PB dash minus PF. Got it? Now place all the values. What is PB? The distance of pole from the object PB. This becomes U. Yes or no? As it is opposite direction of the incident ray, so it will considered as minus U. Okay. So the sign of the is it will be minus U, right? So PB equals to minus U. PC minus PC. PC is the center of curvature, radius of curvature, right? I am writing here PB equals to minus U minus P to C is minus R for concave mirror. Check here. P to C. Does it minus R? Yes. So it is minus R. So later on it will become minus plus minus plus. Now PC again it is minus R and PB dash it is equals to minus. Now tell me what is PB dash? Does it plus V or minus V? PB dash equals to minus V or plus V? Yes, very good. Minus V, students, because it is opposite in the direction of incident ray or left side. So it become minus V. Clear? Now PF. PF means focal length. So does it plus F or minus F? P2F. Yes, P2F. Does it small f? It is small f. So plus F or minus F? Exactly minus F. So here it is equals to minus F. Now again PB dash, we just have taken PB dash as minus V plus F. Minus V minus minus F. Okay. So this will become minus U plus R. Check here. Minus minus become plus. So it is equal to minus U plus R. Then here it is equals to minus F. Here it is minus R plus V. And here it is equals to minus V plus F. Clear, beta? So write the derivation part, what we have got here. Minus U plus R minus U plus R divided by R minus R plus V minus R plus V. Clear? And then minus F upon minus V plus F. Minus equals to minus F upon minus V plus F. Clear, beta? So minus F upon minus V plus F. Now cross multiply these things, all the relations you have to cross multiply. Let us multiply. So minus U plus R whole multiplied by, so minus F plus V. Better you can write it F minus V. Okay. And minus F multiplied by V minus R. In the place of minus R plus V, better you can write it plus V minus R. Okay, beta. Now, here multiply minus U into F become minus UF, minus U into minus V become plus UV, R into F. Okay. And minus RV, that is equals to minus FV and plus RF. Okay, beta. RF and RF get cancelled out. Clear? Now it is what? It is minus UF plus UV minus RV is equals to minus FV. Clear, students? See, we have F is equals to R by 2. So R becomes 2F. So in the place of R, I can replace here 2F. Agree? So minus UF plus UV, and here it is equals to 2FV equals to minus FV. Clear? Yes. So minus UF uh, minus minus UF plus UV equals to minus FV plus 2FV. Agree? So UV equals to F minus FV plus 2FV. So 2 minus 1 equals to plus 1FV. Here it is equal to plus 1FV, and take its transpose it right side. So it will become UF. Got it? Now divided it both side by UVF. Take it some equation number 1 and divide both side by UVF. Right? Divide both side by UVF. Clear? So UV upon UVF equals to FV upon UVF equals to, sorry, plus UF upon UVF. So VF cancel, UF cancel, and UV cancel, and you have the final formula 1 upon F equals to 1 upon U plus 1 upon V. This is your mirror formula. Clear, beta?